Hello and welcome to UILBytes. In this second Boolean identities lesson, we're going to actually look and see how you can use these identities to simplify the expressions. Before we proceed, let's talk a little bit about why it's important to simplify these. Well, these expressions essentially become circuit boards. And on the circuit boards, the and the or, as well as many of the others, are actually pieces of hardware. They are transistors called logic gates. And when you put those on the circuit board, obviously it costs money. And so the fewer you can put on there that still do the same job as your original Boolean expression and idea, the better you're going to be. You're going to have a less expensive device, and therefore you can sell it on the market for less money, possibly making more profit. And of course, in capitalism, time is money. And you want to save as much as possible. Therefore, simplifying Boolean expressions is an important part of hardware design. So let's take a look at these identities again, and we're going to talk about the ones that we discussed in the first lesson and give some examples. So let's take a look at these. Here you have some examples. A or A, that just simply simplifies to A, and that was that law number 1. I called it the melt together law. A and A simply melt together. Same thing here. A and A just simply melt together into A. This becomes B. This becomes B. Now here you have two A's. They can just combine to make one. And then you also have two B's, and then you have a C. So that's as simple as you can get. But you went from 4 OR transistor logic gates to 2 of them, so you have a simpler design. Here you have a very large Boolean expression, but you have several instances of the A, so you can just simply say A once. B can also be put down once. Now the C, E, F, and G, they all occur only once, so you still have to put them. But you can see that you've gone from many AND gates to fewer AND gates, and you have exactly the same expression in the result. Now, the commutative and associative laws are fairly simple, so we're not going to go over those too much. Those almost inherently work when you see them, and we use them here. We just kind of reordered the sequence in which we put the terms. But this is the distributive law, and you're going to use this one quite a bit. So the A distributes over the B and the C, so it simply becomes AB or AC. This would be AB or AC or AD. Here you have a complex expression on the outside. It still distributes over all of these, so you get ABCD or ABEF or ABG, and there's nothing more you can do to simplify that. Now here we have an example of what's called the law of union. Anytime you OR something with a true, with a 1, it just simply becomes true. Here you have many terms, but if any of the terms connected with the OR is a 1, it all becomes true. It doesn't matter what these are. Likewise here, this is the law of intersection. When you AND something with 0, just like in algebra, anything times 0 is 0. So you can associate that level of understanding with that. Here we have many, many terms, but one of them in the mix is a 0. So it basically eliminates all of those, and it's a very powerful simplification tool when you're doing that. So these are just a few examples of how you can use the easier, simpler laws to really greatly simplify a Boolean expression. In the next lesson, we'll talk about some of the more powerful laws like the absorption and De Morgan's law, and you can see how those work. Okay, see you next time.